Welcome to the thrilling realm of AI agents, where machines don't just follow instructions. They learn, adapt, and accomplish tasks autonomously. Today, we're diving deep into the heart of AI agents, uncovering the essential components that drive their intelligence and automation. Get ready to embark on a journey through the building blocks of intelligent automators that could change the future. At its core, an AI agent is a marvel of modern technology. A carefully crafted combination of software and algorithms designed to navigate and interact with its surroundings intelligently. Let's break down the anatomy of an AI agent, exploring the key parts that make it tick. First up, the brain of the operation, the AI component. This is the heart of the agent, the part that makes decisions and determines actions based on the information it receives. AI comes in various forms, from simple decision trees to complex neural networks. The choice of AI depends on the complexity of the task and the type of environment the agent will inhabit. For instance, a basic rule-based system might suffice for a thermostat, whereas a more advanced neural network could be necessary for a self-driving car. Next, we have perception. This is how the agent gathers information about its environment. Think of it as the agent's senses. It can perceive the world through various inputs, such as camera feeds, sensor data, or even text and speech. For example, a robot vacuum cleaner uses a combination of cameras, LiDAR and infrared sensors to understand its environment, allowing it to navigate and clean rooms effectively. Now, let's talk about reasoning and planning. These components are the agent's way of processing the information it receives, deciding what actions to take next. Reasoning involves using logic and rules to draw conclusions from the available information, while planning entails creating a sequence of actions to achieve a particular goal. For instance, in the game of chess, an AI chess engine using and planning to evaluate the current board position, predict possible moves, and plan the optimal strategy to outmaneuver its opponent. Another essential part is the agent's memory. Just as humans retain information over time, agents can benefit from remembering past experiences and using that knowledge to inform future decisions. Memory allows agents to learn from their interactions with the environment, improving their performance over time. For example, a self-driving car needs to remember traffic rules, previously learned routes, and other contextual information to navigate safely and efficiently. Let's now discuss the actuator, which is how the agent interacts with its environment. Actuators are the agent's means of taking actions based on its perceptions and reasoning. They convert the agent's decisions into physical or digital outputs. For instance, in the case of a robot arm, actuators would control the movement of the arm to manipulate objects as instructed by the agent's AI. Finally, we have the agent's architecture, which encompasses the overall structure and organization of the agent's components. The architecture determines how different parts of the agent communicate and work together to produce intelligent behavior. For example, a software agent running on a computer might use a client-server architecture, where different processes run on separate machines and communicate over a network. Understanding these key parts gives us insight into how AI agents function. But it's when we combine these elements that the magic happens. By integrating them into a cohesive system, developers create intelligent automators capable of understanding their environment, making decisions and taking actions to achieve specific goals. That said, designing AI agents are a complex task that requires careful consideration of many factors. One of the main challenges lies in balancing autonomy with safety and controllability. The more autonomous an agent is, the greater the risk if something goes wrong. Therefore, developers must put robust safeguards in place to prevent unintended behavior and ensure that agents remain aligned with their intended purpose. Another challenge is the issue of explainability. When an agent makes a decision that has significant real-world consequences, it's important to understand how it arrived at that decision. This is particularly important in safety-critical applications such as healthcare, where mistakes can be costly. To address this concern, researchers are exploring techniques to make AI agents more transparent and interpretable. Moreover, developing AI agents that can learn and adapt to new situations requires substantial expertise in machine learning and data science. Agents need to be trained on vast amounts of data, and they must be able to generalize well to new inputs and scenarios. This requires not only technical know-how, but also a deep understanding of the domain in which the agent will operate. However, the potential benefits of AI agents are enormous. By automating complex tasks and augmenting human capabilities, these intelligent systems free up our time and resources to focus on higher-level endeavors. In sectors like manufacturing, AI agents can enhance efficiency, reduce waste, and improve product quality. In healthcare, they can assist with diagnostics, treatment planning, and drug discovery, leading to better patient outcomes. Moreover, AI agents can perform dangerous or repetitive tasks, reducing risks to human workers and enabling them to concentrate on safer, more fulfilling aspects of their jobs. Let's dive into some real-world examples that showcase the versatility and impact of AI agents. From healthcare to manufacturing, the business world to the gaming industry, AI agents are proving their worth across diverse domains. In healthcare, AI agents are revolutionizing diagnostics and treatment planning. For instance, IBM's Watson for Oncology uses machine learning algorithms to assist doctors in making more informed cancer treatment decisions based on a patient's unique characteristics and medical history. By analyzing vast amounts of medical literature and research, Watson provides personalized recommendations, helping oncologists develop customized treatment plans that maximize efficacy and minimize side effects. The manufacturing sector is witnessing increased efficiency and productivity thanks to AI agents. For example, in the automotive industry, AI-powered robots are adept at performing repetitive tasks on assembly lines with precision and speed. These agents can handle everything from small parts to large components, ensuring vehicles are manufactured to exact specifications, ultimately enhancing quality control and reducing errors. The business world is leveraging agents to optimize operations and gain a competitive edge. Take Airbnb, for instance. Their AI-powered search engine uses to analyze user preferences, property availability, and other factors to recommend the perfect accommodation for each traveler. This hyper-personalized approach enhances the travel experience and boosts Airbnb's bottom line by increasing bookings and customer satisfaction. Even the gaming industry is harnessing the power of AI agents. In games like chess and Go, AI agents have become formidable opponents, capable of defeating even the best human players. By learning from millions of games and analyzing countless possible moves, these agents refine their strategies over time, providing a constantly evolving challenge for gamers. So whether it's healthcare, manufacturing, business, or gaming, AI agents are leaving their mark and reshaping industries as we know them. To continue our exploration of AI agents, join us in part 3, where we'll dive deeper into the various types of agents and discover how they're categorized based on their functionalities and characteristics. Don't miss out on this exciting journey into the world of intelligent automators. Stay tuned and keep exploring the frontiers of artificial intelligence. As we've seen, AI agents represent a significant leap forward in the world of artificial intelligence. These intelligent automators are revolutionizing industries by automating complex tasks, improving efficiency, and augmenting human capabilities. However, the journey of AI agents is far from over. As technology continues to advance, we can expect to see even more innovative applications of AI agents that push the boundaries of what's possible. In the near future, AI agents are likely to play an even bigger role in our everyday lives. Imagine a personal AI assistant that not only schedules your appointments, but also manages your finances, monitors your health, and even helps you make decisions. AI agents could also help us tackle some of the world's pressing problems. For instance, AI-powered robots could be deployed to assist in disaster relief efforts, exploring hazardous environments and providing much-needed aid in hard-to-reach areas. However, With the rise of AI agents also comes a set of ethical challenges that we must address proactively. As these intelligent systems become more autonomous and capable, it's crucial to ensure that they remain safe, reliable, and aligned with human values. We must also be mindful of the potential impact of AI agents on employment and the economy, and take steps to mitigate any negative consequences. Overall, the future of AI agents is bright. With continued research, development, and responsible implementation, AI agents have the potential to improve our lives in countless ways. So let's embrace the possibilities and work together to ensure that AI agents benefit all of humanity.